in this question, we are going to implement the HashMap, but we are not going to use the built-in HashMap library. So that's the reason we need to use other data structure. So here, the first method is to the integer array. As the node here, you can see all the keys and the value will be in the range of 0 to 1 million. So in this way, initially we need to initiate a integer array with a size 1 million. So no matter how many times we operate the hash map, we still need 1 million. So it's a big space. So for example, if you want to put the 3 and the 100 as a key and a value, so you just update it here. All right, and if you want to update key 7, so you just update it here. So if you want to get, right, if you want to get the let's say you want to get the key 8 value, and then there's nothing there, so you're going to return -1, right? And if you want to remove the key remove key 7, right? If you want to remove key 7, then you're going to remove this, then it turns back to x. Maybe not x, maybe the default value should be -1, right? That doesn't matter. So in this way, the time complexity is 01, and the get complexity is 01, and the remove 01, because when you put, you just find it and put, you get, you find it, and you remove. For example, you find a 6, and then you just remove the information here. We can initiate the integer array, the default value as -1. So how to optimize this algorithm? So what if the hash map we will only use like 100 times, right? Maybe like 1000 times, so, or maybe even 10 times. So this is a big waste. So that's the reason we will consider about using the hash and chaining. Okay, so we can read this. So now probably we can just make a it's not integer list, it's a list node array. So each element here is a list node. So the list node has the key and also the value. Okay, let me repeat again. So each list node has the key and value. So for example, if you want to put a 5009, then you are going to hash using this one to mod 500, because the size is 500, and then you see the key is, no, it's not key, it's index. So you move your index here. So basically you move your index here, right? You move index here, and then to see if the 5009, if it is already exists in this list. So this is the list node, but they are connected together. It's kind of like a linked list. Okay, so if you didn't find 5009 in here, and then you are going to add, right? You're going to add 5009 and 200, right? So you add the list node here. So this is another new list node here. But if you already find 5000 here, for example, the next time you just update it like 3, 4, 5, and then you just continue to find the key, right? You find the case index, which is here, right? Which is at here, and then you continue to find, if you can find the key 5009, then you find it and then you update it, right? And the same story, if you want to remove 5009, and then you're going to find the key, you're going to find the index, which is 9, and then through the index you find this one, and then remove it. And if you want to get, right, same story, if you want to get like 5009, and then use also using the hashing. So this action is hashing. You find the index 9, and then just remove it. So in this way, that we optimize the space complexity, because previously, no matter how we do the question, we still need the space with 1 million, but now we only need 500, right? And what's the put complexity is actually O(n), right? Because O1 to find the index and OK to find the list node, right? Let me repeat again. So each of these is a list node. So the K. So case means the learns of the list node list. The list node. Yeah. For example, this one, the learns is 1, 2, 3, 4, 5, right? And get is also the okay, because whenever you find this, you're gonna search one by one. Is okay. Remove is also okay. Node array index, okay. And so I'm going to use the key mod the nodes learns, right?
Yeah.
Actually, we can define the learns here. Okay, so that's the initiation. So when I actually we can put it here. So we define this and initiate it here. Okay, and after that, so now I'm going to put the key and the value in the whole bucket. I mean in this whole bucket here. But how am I going to put it here? So I'm going to move the code here for better explanation. So in case we have this bucket here, like this. So the first one I'm going to generate the key, right? Generate index against the key. So we have the index, right? And after I will see if the index in the list node array, if it is empty, if it is empty, and I will make it as it's kind of like a header in each bucket. It's like a list node -1 -1. So this one is useless. It's just to make sure that this bucket has been used or not. Okay, if it is not being used, if it is equals to none, it means that it has never been used. So I'm create this one, and okay, put, because I need to put this okay. I think I need another function is I need to find the this node which contains the key. So I'm going to there's a function I'm going to implement later. So the function will give you a key and give you the nodes index, right? Right. So we have the bucket here. And then we give the key. So I'm going to search the key in this bucket to see if it exists. So that's the reason I need to implement find key, and also list node. List node what? Bucket, right? Okay, so firstly I have to see if the bucket, let me see, if the bucket is already equals to now, and then return -1, because if the bucket is not exist, right, and then there's no way to find. Otherwise, I'm going to define this node prev now, and while bucket not equal to now, and this bucket's value the bucket key is not equal to key, right? So I'm using this way to check one by one in this bucket. So the meaning is that the bucket is like a chain. I mean, get connected all the have a connection of all the existing list node, and if the bucket is the key is not to the key that I am going to find, and so it means that I didn't find the key. So in this way, I'm going to move the bucket forward, right? Yes. After that, I need another. Okay, I'm going to explain why I need pointer as like pre. So for example, now so the bucket is here, and then the pre is here. So the pre is always the position, just one element behind the bucket. So that's the reason I need to assign the bucket to the pre first, right? If somehow I find if somehow I find the key is here, right? And then I'm going to let me see. If somehow I found the key is here, and then I can return pre. If somehow I found the index is here, which is empty, but I still can return the pre, and then I'm going to use the pre to test if the bucket is a valid one or not.
How do you return the list node since your return type is integer?
Oh, I'm sorry. I'm going to return the list node.
Okay.
Okay. Yeah. So it's a little bit tricky here because I'm going to use the pre stuff here, and then the reason why I need to use the pre because I need to find the position of the previous one of the bucket. Because later I'm going to attach the new node after the pre or after the bucket. Okay. So this is so this is the function. Okay, so this is find the elements with key input. Okay, now
go back to the find function.
Yes.
So for the function first statement, if bucket equal to none, so you're gonna return -1. So basically here you don't have you should return list node and
if the bucket is I'm going to return.
What will you like return for this type thing? Yeah. Okay, you just return none. Okay.
Yeah, I think I'm going to remove this one. Yeah, if the bucket is not exist, so I'm just return the pre, right?
Okay, cool.
Yeah. Okay. Thank you for the information. Okay, so now I'm going to put the value. So I find the previous one. So I use the function to find the previous node. I mean behind. Before the bucket. So if the pre next is equal to now, so it means that we don't even have the key in the whole bucket container, right? So in this way, I'm going to pre next equals to new next node. The next node will have like key and the value, right? And otherwise, then the pre next value should be equal to this value. Do you understand this part?
Yeah.
Do you need me further explain this part?
It's okay. I understand this part. Yeah.
You understand it, right? Okay. So it means that if the bucket is not exist equal to none, and then I'm going to add the new node after the pre node. Otherwise, the bucket, which is the pre next, already exists, and then I'm going to update the value. Okay. Now I'm going to implement get. So the same stuff here is I'm going to copy here. So I have to find the index, and I'm going to if the index is equal to now, I'm going to return what? Return -1 because it's not exist, right? If it is not equal to now, so it means that we have get the key. Okay, if I want, so now I get the bucket here. If the bucket exists, so while the bucket wait a minute. Oh, I need to use the same stuff here. I need to use this to find the key here. Find node here. If I think there's similar structure here. So if it is equal to now, I'm going to return -1 because it's not exist. Otherwise, I'm just going to return pre next value. Let me see. Right? I think it is correct. So I get an index, and then according to the index, I find the bucket, and then through the bucket, I'm going to find the previous one of the target. If the target is equal to now, I'm turning. Otherwise, I'm going to okay. Then how to remove? I think the remove is the same stuff. I'm just copy this one here. Find the index, and to see if it exists. If not exists, then just return. If it have the bucket, and then find a possible position. If pref next equal to now. Okay. Then I'm going to just return because there's nothing to remove. Otherwise, the pre next should be equals to pre next, right? I'm going to remove the pre next. Okay.
Are you done?
Yeah, I think I'm done.
Do you need to review your code?
Yes. So firstly, I'm going to create a list node with this structure. the next node will store all the information. I mean, store the pair.
Yeah, check the syntax for the rest of code. Yeah.
Okay.
Yeah.
It's okay. Final here. Generate the key here. Find function. So I think this one is a key function here. So we need to use the find to get all the information.
Okay.
And HashMap will initiate this stuff. I mean the list node array, and put is like I'm going to find if it exists. If not, if the bucket is not exists, and then I will initiate this one. And also find this one. If it is if we couldn't find the key, and then I'm going to put a new list node with the key and the value pair at here. Otherwise, I'm going to renew this one. Okay, get.
Okay, back to the last function, the last statements. No, I mean the previous one, the put. The else is wrong.
Oh.
Yeah. Okay, keep going.
Okay. Okay, it's get. I think this structure is pretty same stuff.
Okay, you have another problem for the get function.
Yes.
You return the value for the if else parts. You need to return. It's the return type for the function as integer. For the last statement, your f previous next equal to none, return -1, else you need to return the previous next value.
Yes.
Yeah, it's better to have a breaks. Yeah. 一个括号吧。
Okay.
最好不要这么写啊！你这个最好写一个括号给那个 else 这样子一致的话，
Okay.
那就写个括号。
Yes, you're right. Else just return this one. Okay, I passed. Okay.